Why are you crying? You cannot understand finite element analysis. Okay, don't cry. I will tell you a story of a police and a thief today. In a town, there was a thief who used to rob, who used to steal things, and used to run away. Police cannot catch since he used to cover his face and facial expression, and sometimes or many times he used to hide himself among the others. So police find it very difficult to find the thief. But the police has one idea. An idea clicked into police mind. So what smart police has done? Smart police discretize the problem into small boundaries, as it was very difficult to find the police, to find the thief, as it was very difficult to find the thief among all the people. So he discretized the problem. He divided all the people into small group, which is called discretization. Hence he was able to inquiry all the peoples in separate group, although it took time. However, because of this technique, he was able to catch the thief. So moral of the story is, life problems are big, but it can be easily solved if you discretize the bigger problem into smaller elements. So finite element analysis is just like real world problem, where we discretize the bigger problem into smaller parts. Now, what is FEA? Problem in life is infinite. Continuum we call in FEA, which is infinite. You cannot count it. You need to break it into small chunk or small element, just like the police and thief story. So finite element analysis or method is about solving a real world problem by discretizing into finite element or countable element and solving it. The history of FEA started with structural engineering. Now vehicles move across the bridges. However, before designing bridge, you must know total deflection and stress which the bridge must withstand, or else it will be same like Tacoma Narrow Bridge, which totally collapsed. It's sometimes called hanging bridge because it was designed wrong, because engineer failed to understand or calculate the total stress, total deflection. That's why it collapsed. How it collapsed? The wind velocity at that day matches the natural frequency of the bridge, and hence bridge collapsed. So how finite element works? We will take the case of the bridge. Now finite element analysis will convert the real world problem into countable number of small elements, which is called element. Now you can see here, this is a bridge structure. Initially it was a big problem. I will reverse this video again. Now you can see this is a bridge. It is a continuum problem. You don't know about what will happen, what will the stress, what will the deflection. So just like police and thief problem, you need to divide this continuum or infinite problem into countable number of elements. Now you can see this is the process. This process is called discretizing into countable number of elements. Now this process of dividing the infinite problem into countable number of element is called meshing. Just like police and thief, how police caught the thief. Now the meshing process. What is meshing? Now if you see, finite element analysis is all about converting infinite problem to countable elements. So this process is called meshing. However, the type of meshing depends upon the problem. Now you can see a bridge. So for example, 1D element, when we will be using 1D element, when the length as compared to the cross section is more, just like bridge, then we are using 1D element, and it is used for approximating results, and when computational factor are not predominant. Now 2D element. 2D element are sometimes called substitute of solid element. It is generally used for seat structure, for example outside body of car. However, it doesn't give more accurate result. However, it is used when computational parameter is not predominant, because it takes less time as compared to shell type of elements. Now 3D element. 3D element or solid elements are used by maximum of the engineers. However, it is time consuming. More computational time is required for this. Now which meshing to choose? Now if you go for solid meshing, solid element, you might be getting accurate result. However, it will be time consuming, so more computational time. If you want more accurate result and closer to the experimental results, you need go for solid meshing, which is being used by engineers. However, it is time consuming. Now nodes. What are nodes? Now if you can see, FEA, we are trying to divide the infinite problem into finite countable elements. Now nodes at the corner point of this element, where you are going to put the boundary condition to find the field variables. Field variables are unknown, which you need to find. For example, diffraction, stress, pressure, which are unknown to us. Now after, so we have checked nodes are the corner points. So once meshing is done, after meshing you need to put properties like Young's modulus, boundary condition, and load. These things are required to define the system. Young's modulus is required to know which type of material it is. Boundary condition is required, how the system is going to behave against the external load. So once it is done, then after the load is being applied, all elements go displacement. Now from each displacement we get stiffness. Now each element stiffness is obtained and added. So you can see here, stiffness matrix for single element is taken and then it is added to all the elements. So we got a bigger matrix. For example, for element 1 we got this matrix, for another element we got this matrix. Similarly, the process goes on. It depends upon the size of meshing, or the smaller the element, so it goes on. It can go up to infinite times. Now computer need, or you need to add all these elements. So finally you will get a matrix which is very bigger in size for the whole system. This is called addition of matrix. So once matrix addition is done, you're going to get the results, which I will show you in previous slide also. For example, force is equal to K into U. K is what? K is our stiffness, force is the load which we know, U is a deflection which is unknown. So by solving the matrix assembly, you are going to calculate the total unknown variable, which we call it filled variable. So filled variable are calculated by the known terms. Here filled variable are displacement, stress, temperature, pressures, and list goes on. It depends what you want to calculate. So FEA can solve any type of problem. This is a fundamental concept. Property, it is called stiffness, which will be given the problem. Then how behavior which you need to calculate, and F is the external force which is acting, a load. This was the flow process of FEA. Hope you understand. Like and subscribe.